In the previous lecture, we talked about variation of parameters. This is a method for solving linear second-order non-homogeneous differential equations. Yeah, we said we are going to follow these 5 steps for solving second-order ordinary differential equations or higher-order differential equations by using variation of parameters. Here, we should first identify a and f of x. A is the coefficient of the second order term. This one is A, and this is A, and also f of x. We should first identify these two. That's in the first step. We just say A is this and f of x is that. And now we determine the homogeneous solution. For the homogeneous solution, we just take the homogeneous part. That means we let f of x be 0, and we find the homogeneous solution by using the characteristic equation. After finding it, we get two solutions. Let's say A, y1 plus B, y2. Here, y1 and y2 are two solutions for the differential equations. These two are the homogeneous solutions. From the homogeneous part, we get two solutions, y1 and y2. Then, in step 3, we are going to find the Jacobian of y1 and y2. How? We say we are going to make a determinant y1, y2, and their derivatives y1 prime and y2 prime. Then we find the determinant of this matrix. The determinant of this matrix is multiplying these two minus multiplying these two. It's this. This is W, which is the Jacobian of y1 and y2. Then we find u and v. What's u? We say u is minus the integration of y to f of x divided by a times w. W is the Jacobian. A is the one which we found in the first step. F of x is the right hand side, and y2 is the solutions that you get, is the second solution that you get from step 2. This for u, and v is the integration. Here we have no negative sign for v. We say it's the integration of y1 times f of x divided by a times the Jacobian. We find these two integrations. After finding them, we get u and v. Now we have u and v. And before, in step 2, we found y1 and y2. What we do, we say the solution, which is the general solution, is u times y1. We don't multiply u by y2. We multiply it by y1. U times y1 plus v times y2. This is the general solution. So you have only these 5 steps to follow for solving second order or higher order ordinary differential equations by using variation of parameters. And we solved an example by this method. We now have another example. In this example, we have given y double prime minus 4y prime plus 4y equals 1 plus x e to the power 2x. This is the differential equation. This one is the differential equation. And here, in the first step, what we do, we are going to identify a and f of x. What's a? As the coefficient of y double prime. So here, we say a, step 1. A equals 1. And f of x equals what? Equals to the right-hand side, which is x plus 1 times e to the power 2x. Okay, this is step 1. And now, for step 2, what we do, we are going to find the homogeneous solution. For the homogeneous solution, this is step 2. Find y h. To find it, we first should write down the characteristic equation. So the characteristic equation is m squared minus 4m plus 4 equals 0. Okay, It's m squared minus 4m plus 4 equals 0. Now we solve this polynomial of degree 2. It is by factorizing, we get that m minus 2, m minus 2. As you see here, you have two repeated roots. That means m1 equals m2 equals 2, is it? Okay. So here, m1 equals m2 equals 2. As you see here, from this one, we get m1 equals 2. And from this one, we get m1 equals 2, m2 equals 2. That means m1 and m2 are equal, which is 2. Here, m1 and m2 are both 2. Now we have two repeated roots. As we said before, at the beginning of the chapter, we said if we have two repeated roots, then the general form of the solution is, we say y h equals a plus bx times e to the power mx. Okay, this is the general form of the solution if we have two repeated roots. So now m is 2 because both are equal. That means the homogeneous solution is a e to the power 2x plus bx e to the power 2x. This is the homogeneous solution. This is the homogeneous solution. We just multiply this into the bracket and we replace m by 2. That's all. So now we have two solutions for the homogeneous part. We have y1 equals to what? And y2 equals to what? We should find y1 and y2. y1 is this one. Or may someone else choose this one for y1? It's okay. Yeah, y1 is e to the power 2x. And y2 is x times e to the power 2x. We take all except the constant value. Here we have y1 and y2. This is step 2. In step 2, we just find y1 and y2 from the homogeneous solution. And then in step 3, we should find the Jacobian of these two solutions. We say step 3, what we do? We are going to find w, which is the determinant of y1, y2, y1 prime, y2 prime. It equals to, what's y1? y1 is e to the power 2x. Now, what's y1 prime? It's 2 e to the power 2x. We just take derivative of y1. And y2 is x e to the power 2x. The derivative of y2 is first times derivative of the second plus second times derivative of the first. It is 2x e to the power 2x. It's first times derivative of the second plus second times derivative of the first is this. We find this determinant, multiplying these two minus multiplying these two. So in multiplying this direction, we get e to the power 2x multiplying by 2x e to the power 2x plus 2 e to the power 2x. Then minus multiplying 2x, 2e to x by x e to the power 2x. We get 2e to x times x times e to the power 2x. This is the determinant. We just multiply in this direction. I mean, from u, we multiply these two minus we multiply these two. Okay. Yes. Yes, that's e to the power 2x. Thanks. Derivative of x e to the power 2x, we say first times derivative of the second plus second times derivative of the first. So it's just e. Oh. Plus e to the power 2x, is it? That's it. Now we simplify the determinant. we say it equals to. So W equals. We first enter this E into the bracket. We get 2x e to the power 2x times e to the power 2x is e to the power 4x. We get e to the power 4x plus e to the power 2x times e to the power 2x is e to the power 4x minus 2x e to the power 4x. We multiply these two, we get. Now these two are similar and they have different signs. These two are cancelled out. So W equals, which is the Wronskian, oh, so Jacobian, is e to the power 4x. This is the Jacobian. Okay, this is W. This is step 3. In step 3, we just do that. In step 4, we should find U and V. We should find U and V. Step 4, we should find U and V. We say U equals minus integration of y2 times f of x dividing by a times Wronskian dx. Okay, plus c. So this equals to minus integration of what's y2? We found y2 before, which is x e to the power 2x. That's x e to the power 2x times f of x. F of x is the right hand side, and it is this one, which we find in the first step. In first step, we identified both a and f of x. F of x is x times e to the power 2x plus e to the power 2x. We enter this e to the power 2x to the brackets, and we get x e to the power 2x plus e to the power 2x. This is f of x times x e to the power 2x plus e to the power 2x dividing by a times a is 1. A is 1 times w. W is e to the power 4x. This is dx plus c. We now look, we just insert this exponential into the bracket. Look, we have this, which is f of x. This is f of x. Yeah, we multiply this into the bracket. We get this one. And now we say y2 multiplying by f of x. What's y2? Y2 is x e to the power 2x. And f of x is this one. We multiply these two. I've just written down this. That's it. This is y2, and the bracket is f of x. We just multiply them. And now we enter this x e to the power 2x into the brackets. We say x e to the power 2x times this term, then times this term. What we get? When you multiply it by x e to the power 2x, what you get? We say u equals minus integration. First we simplify it, then we find its integration. We get x squared e to the power 4x plus x e to the power 4x. Is it? So the denominator is e to the power 4x dx plus c. It equals to. Now, between these two terms in the numerator, we can take e to the power 4x as the common. Here, we have, between these two, we have e to the power 4x as the common. We take them, we take it from them, and we get minus integration of e to the power 4x. So what's left? We get only x squared plus x. Is it? Dividing by e to the power 4x. These two are cancelled out. That means u equals minus integration of x squared plus x dx plus. and it's easy to find. The integration of x squared plus x is x cubed over 3 plus x squared over 2. That's equal. اگر هات زیادتی لیک هنی تیابت اگر چی نبوده اگر کنون نبوده او کاتا بوده برای با substitution بید با او نبید چون که جیره که نخیب برید بالا رگه کربی بوده باشه بالام شتیوه نعده شتیوه قرص نعتره تن کنکت شتیوه که نعتره کنکت integration. Okay, so here it is minus x cubed over 3 plus x squared over 2 plus c. This is u. This is u. Now to find v, we do the same, but the formula is different for v. We just have this negative sign, and instead of y2 we have y1, and that's all. We say v equals integration of y1 f of x dividing by aw dx plus we choose another constant, let's say d, and so v equals integration of what's y1? We found y1 before, and it is e to the power 2x. We found this. It is e to the power 2x times f. F is x ex e to x plus e to x. This is f of x. That's it, as you found here. This is f of x. Dividing by a times w. A is 1 times w is e to the power 4x. This is w. All dx plus c. Now we try to take common between the numerators with the terms in the numerator to cancel out with the denominator. So v is, I'm just going to write down the result, okay? If we take e to the power 2x from the bracket, we get e to the power 2x times e to the power 2x in front of the bracket. We get e to the power 4x. So you get e to the power 4x times x plus 1 d, all divided by e to the power 4x dx. Here we have d, sorry, it's not c. Okay? And here we get v equals the integration of this, so I cancel out. We get x plus 1 dx and equals to x squared over 2 plus x plus d. This is v and is u. Now we have u, v, y1 and y2. In step 5, what we do? In step 5, write down. Step 5. In step 5, we say y of x equals u times y1 plus v times y2. We found these 4 functions. U is this function. This is u. And this is v. And we found y1 and y2 before. y1 is e to the power 2x and y2 is x e to the power 2x. This u, which is minus x cubed over 3 plus, let's say, minus. I'm going to enter the negative sign. We get minus x cubed over 3 minus x squared over 2 plus c multiplying by y1. y1 is e to the power 2x. Then plus v times y2. v is x squared over 2 plus x plus d multiplying by y2. y2 is x e to the power 2x. Now enter these two exponential functions to the brackets, you get the result. So y of x equals, let me write down here, y of x equals minus x cubed over 3 e to the power 2x minus x squared over 2 e to the power 2x plus c e to the power 2x plus, we enter this to the brackets. It's for all terms, for all three terms. As we get plus x squared over 2 x e to the power 2x plus x squared e to the power 2x plus d e to the power 2x. If there is any simplifying, we do it, or any cancellation we do, we get y of x equals. We have only one term with x cubed. We just write down it. Minus x cubed over 3 e to the power 2x. But for x squared, we have this term and this term, and also this term. Okay. So here we have the x cubed. It's x cubed. Okay. Yeah, it becomes x cubed. Here you have x cubed over 3 plus x cubed over 2 e to the power 2x. We can add or subtract these two together. And for x squared, we have minus x squared over 2 e to the power 2x plus x squared e to the power 2x. Then for the constant terms, we have c e to the power 2x plus d e to the power 2x. We have, do we have else? We have nothing else. Yeah, that's all. Now we have these two. The sum of these two is, we find the common denominator. The common denominator here is 6. That is 6. Now we get it. We get that the common denominator here is 6. Y of x equals 6. X cubed e to the power 2x. And between these two, what's the common denominator? It's 2. Okay, and we get plus a half of x squared e to the power 2x. These two are the same. Plus c e to the power 2x plus d e to the power 2x. This is the solution for that differential equation. Okay, that's the solution for that differential equation. Okay, do you have any question? Just following those steps, those 5 steps. First, we identify a and w, a and f of x. In the second step, we find the homogeneous solution. In the third step, we find w, which depends on only y1 and y2. In step 4, we find u and v from these two formula. It's u, that's v, which depends on y2, f of x, w, and a. And then after finding u and v, multiply u by y1 and v by y2, which is the general solution. That's it. Here, there's a list of exercise that's for yourselves. And now we have some applications of second order differential equations. So let's take a break. 5 minutes. We now have another section in this chapter, which is the last section. It's about application. Sorry. We have 2 applications for second order differential equations, ordinary differential equations. First, we have mechanical vibrations. For mechanical vibrations, we say we use this second order ordinary differential equation for solving mechanical vibrations problems. We say where m, here we have m y double prime plus by prime plus ky equals f of t. This is the general form of mechanical vibrations equation. Here we use this equation for solving mechanical vibration problems. It says M is mass. M is mass. B is the damping coefficient. B is the damping coefficient. K is the spring constant. It's the constant which is related to the spring. Sorry, I don't know. I don't know what's Hooke's law. Yeah. Here, F of t is the force or external vibration. Here we have some cases. It's for the general equation. We say if we have undamped free vibration, that means we have no vibration. It's free vibration, means we have no vibration, and it's undamped. That means we have no damping constant. So the damping constant is 0. And also the vibration, the external vibration or the force is also 0. That means here F of t is 0 and B is 0. If you replace B and F of t by 0 in the above equation, what we get? We get my double prime plus ky equals 0. This is the equation. Here in this case, if you have no damping and no external vibration, we say we use my double prime plus ky equals 0. So generally, if you just know this equation and you know what's M, what's V, what's K, and what's F of t, that's all. You don't need to memorize these. Okay? You don't need to memorize these cases. Here it says damped free vibrations. That means we have damping, but we have no external vibrations. Means F of x is 0. But B, we have its value. That means we have B, but no F of t, F of x. And if this undamped but forced vibrations, that means we have F of x, but you have no B. That means B here is 0 because it's undamped. So the damping constant is 0. But here you have forced vibrations, which is F of t. That's it. And if it's damped forced vibrations, and it means if you have damping constant, and also if we have forced vibrations, we use the general form of the equation. That's it. So generally, we use this equation. If it says it's undamped, means B is 0. If it says there's no external force or external vibrations, means F of t is 0. Here we have an here before we solve the example. Here we have the conditions. Initial condition, which is initial displacement. Y of 0 equals alpha. This is the initial displacement. And y prime of 0, so we say the derivative of displacement is velocity. The derivative of displacement is velocity. We say y prime of 0 is v, which is the initial velocity. We say if this upward, its sign is negative, and if it's downward, it is positive. It's given in the example that it's either upward or downward. Okay. And y of t, which is the general solution of the differential equation, is the displacement of the spring at any time. Here we have given an example. It says the response of an overdamped system to constant force is governed by this equation. This is the equation. We have given the equation here. We don't need to construct the equation. It's given here. And it says y of 0 equals 0 and y prime of 0 equals 0. We should compute the displacement y of t. That means we should find y of t. What's y of t? Y of t is the general solution for this differential equation. That means here, since that's not homogeneous, we should find both homogeneous solution, and particular solution. After finding them, we just find the sum of them, which is the y of t, and the general solution. And it says, what happened when t approaches to infinity? That means if time goes to infinity, what happened? What about the displacement? Okay, let's solve the differential equation first. For solving this differential equation, we have two types of solutions, which are homogeneous solution and particular solution. For the homogeneous part, we say to find YH. We should first write down the characteristic equation, which is m squared plus 8m plus 6 equals 0. Here we cannot factorize this. If we can't factorize the polynomial or the characteristic equation, what we do, we are using the quadratic law. Here we say m1 2 equals minus b plus minus square root of b squared minus 4ac dividing by 2a. Here a is 1, b is 8, and c is 6. So m12 equals minus b, which is minus 8, plus minus square root of b squared, which is 64, minus 4ac, it's 24, dividing by 2 times a, which is 2. Now we simplify this, we get that m1 and 2 equals. Here we get minus 8 plus minus 2 square root of 10 dividing by 2. Now we can cancel out, or we can take 2 as the common between the terms in the numerator to cancel out with the denominator. And you get that minus 4 plus minus square root of 10. This is m1 and m2. This is m1 and m2. After finding m1 and m2, these are complex numbers. We said for the homogeneous solution, if the characteristic equation has two complex numbers, has two complex roots, we say YH equals e to the power alpha x. Here we have t. As you see, the independent variable here is t, alpha t times cosine beta t plus, here I forgot to write down the constant here. And you say a cosine beta t plus b sine beta t. Here we just replace alpha and beta by their values. What's alpha and what's beta here in the complex number? Here alpha is the real part. Sorry, it's both real. I'm really sorry, it's not complex. Why didn't you tell me? Here we have two different roots. m1 equals 4 plus square root of 10 minus 4 plus square root of 10, and m2 equals minus 4 minus square root of 10. Here both are real, they are not complex. That means YH equals a e to the power m1x, which is minus 4 plus square root of 10x, plus b e to the power m2, here it's not x, it's t, the independent variable here is t, e to the power m2 t, which is minus 4 minus square root of 10 t. This is the homogeneous solution. And here we should find the particular solution also. We should find the particular solution. Look, in the applications, you are free to use which method for finding the solution. Here you can use variation of parameters, or you can use undetermined coefficients for solving this differential equation. Okay, here I'm going to use the undetermined coefficients. We say for yp, let yp equals to what? The right hand side is a constant, so we just let yp to be, let's say c. We let it to be a constant. If it's only a constant, we say we let it to be a constant. So from this, y prime of p equals y double prime of p, which is 0. Both derivatives are 0. Now we replace y by c. y prime and y double prime by 0 where in the given differential equation. So here we get y double prime plus 8y prime plus 6y equals 18. This is the differential equation. Put y prime, y double prime in this equation. So you get 6c equals 18. And so c is what? Is 3. We found the value of c. That means yp equals 3. We now have both yh and yp. We have both. Now we say y of t equals yh plus yp, which is e to the power minus 4 plus square root of 10 t plus b e to the power minus 4 minus square root of 10 t plus the particular solution is 3. This is the solution for the differential equation. This is the displacement at any time. This y of t, which is the displacement at any time. Now we have given two conditions. We have given y of 0 is 0 and y prime of 0 is 0. We have given these two conditions. Here, we use these two conditions for what? Why do we need to use these two conditions? We use these conditions. We always use the conditions for finding the values of constants. Okay, we always use conditions for finding the values of constants. Here we have two constants, a and b. So we have given two conditions also, y of 0, 0 and y prime of 0, 0. Here, apply the conditions. Apply the conditions. We say y of 0 is 0. That means a plus b plus 3 equals 0. Is it? From y of t, we replace by 0 and we replace each t by 0 also. Here we get e to the power 0 and e to the power 0. That's 1. So you get only a plus b plus c plus 3 equals 0. And for y prime, we find y prime of t. We just take the derivative for that function. Because here we have given y prime of 0. So you should first find y prime of t, then we apply the condition. You see, for this one is that. And for let's first find y prime of t. So what's y prime of t here? It's minus 4 plus square root of 10 a e to the power this t. I'm not gonna write down the again, okay? It is minus 4 plus square root of 10. It's plus square root of 10. Then plus, so minus plus minus 4 minus square root of 10 times b e to the power this equation. This is the derivative of y of t. It's derivative of the displacement. Now you say for y prime of 0 to be 0, here we replace y prime by 0 and we replace each t by 0. And you get minus 4 plus square root of 10 a plus, so it's minus, let's say plus, okay, 4 minus square root of 10 b equals 0. We have these two equations. We have these two equations. We say this equation 1 and this equation 2. Now solve equations 1 and 2 to find the values of a and b. Then put it of a and b in y of t. And that will be the results. That will be the final answer. So after finding the values of A, here we have two linear equations. You can use a determinant or any other way for finding the values of A and B. You can use substitution, you can use elimination, or you can use the methods of matrices. You can use Gauss Jordan, Gauss elimination, grammar rule, or any other way to find the values of A and B. Okay. Okay, okay. So what you mean? Okay. After finding the roots, I mean after finding M1 and M2, here we find YH. This is YH. Look, we say if we have let's say AY double prime plus BY prime plus CY equals f of x. It means if the right hand side is not zero. In this case, we should have both homogeneous and particle solutions. For the homogeneous part, we equal this to 0 and we find the characteristic equation and you get M1 and M2. After finding M1 and M2, we write down YH. That's for the homogeneous solution. And for the particular solution, we depend on the right hand side. If the right hand side is a polynomial of degree n, we just write down the general form of the polynomial of degree n. But here we have only a constant, which is 18. So 18 is a constant. That means we let yp to be, let's say, c. We find the derivatives as we have in the given equation. We have y double prime and y prime and also y in the given differential equation. So we must find y prime and y double prime from y of t. And then we return to the equation. We equal to the right hand side to find the value of constant there. Here, finding y prime and y double prime. These both are 0. And y is c. We return these to the differential equation. We get that 6 here, depending on the given differential equation in the example. We have 6c equals, we replace y by c. Okay. And here we have y prime and y double prime. These two terms are 0 because y prime and y double prime are 0. We have 6c equals 18. And so c is 3. So now we have yp equals 3. This is yp because yp equals only c. So now we have yp and the homogeneous solution also. We say the general solution is the sum of these two solutions, is the sum of a homogeneous solution and particle solution. We have y equals yh plus yp. We found this and we found this. Okay, let is e to the power m1x a plus this ct plus b e to the power m2t plus 3. This is y of t, but we have given two conditions. We use conditions for only finding the values of constants. In the solution, we have two constants, which are a and b. Okay, but be careful. You should use the conditions in the general solution, not in only the homogeneous solution. You should use it here, not in the previous solutions. It's the sum of both particular and homogeneous solutions. We should use it here, not in only the homogeneous solution. Here we have y of 0 is 0. That means if you replace t by 0, we get y equals 0. That means in the solution, we replace y by 0 and t by 0. What we get an equation. This becomes 1 and this becomes 1. We get a plus b plus 3 equals 0 because y is 0. This is the first equation. And then we have given another differential equation. Another condition. We have given another condition, which is y prime of 0 is 0. That means when t is 0, then y prime is 0. From y, which is yh plus yp, we are going to find y prime. We are going to find y prime. And then it equals to an equation. In this equation, we replace y prime by 0 and t by 0. We replace both by 0. Yes, it's given. It says y of 0. Here we have y of t equals to something. How about y of 0? Means t is 0. Okay. How about y prime of 0? That means in the derivative, we replace t by 0. That's it. So here we find two equations. The equations are this one, which includes a and b, and this one also includes a and b. You can use either substitution or elimination or any other method for solving this linear system. It's a linear system. You can solve it and find the values of a and b, then return the values of a and b to here. Return the values of a and b to here. And it will be the final answer. So that's all. I'm going to leave it for yourselves. Okay. Finding that for yourselves. That's easy. Only calculations to find the value of a and b. Now we have another example. It says a 3 kilogram. It's so easy, no worries. It says a 3 kilogram object is attached to a spring. Look, here we have a spring. We have 3 kilogram. We have 3 kilogram, which is attached to a spring, and it stretches the spring 392 millimeters. So the stretching is 392 millimeters. The object stretches the spring 392 millimeters by itself. There is no damping. That means B equals 0. As it says, there is no damping. B equals 0. First, here we have not given the equation. We should write down the equation. The equation is this one. This one is my double prime plus by prime plus ky equals f of t. Okay. My double prime plus by prime plus ky. This is the equation. My double prime plus by prime plus ky equals f of t. We use this equation. You should know this equation. You should memorize it. Here b is 0. That means we have no this term. B is damping. As there is no damping, means b is 0. And the forcing function is 10 cosine 5t. So what's this? It's the right hand side. F of t is 10 cosine 5t. F of t equals 10 cosine 5t. Is acting on the system. That means you have forcing vibration, as we talked about before. The object is initially displaced 20 centimeters downward. Look, it's downward, means it's positive. As we said, if the initial displacement, if it's downward, it's positive. But if it's upward, that is negative. And here it's downward. So that means y of 0. This is the initial displacement. Y of 0 equals 20 centimeters. From its equilibrium position and given an initial velocity. This is the initial velocity. We said the initial velocity is y prime of 0. Look, we talked about this before. This is the initial displacement, and this is the initial velocity. Okay, it's given that it equals to 10 centimeter per second square. It's 10. It's upward. That means this negative. Since that's upward, means it's negative. We said if any of them, the displacement or velocity is upward or downward. If it's upward, it's negative. If it's downward, it's positive. So it's minus 10 cm per second square. So it's enough for today. Okay, I'm gonna finish this example by tomorrow, and then the next example also. The next example is solved. Actually, I'm just gonna talk about this. It's about RLC circuit, and then we start the new chapter, chapter 3, by tomorrow. So it's enough for today.